Hello, this is Miss Moore, and today during chemistry we're going to discuss carbon and organic chemistry. Today's essential question: how are organic compounds different from inorganic compounds? Please make sure you fully answer this question in your summary. So what is organic chemistry? Well, organic compounds are those made of carbon and hydrogen. They can also contain the atoms oxygen, nitrogen, sulfur, phosphorus, and the halogens like fluorine, chlorine, bromine, etc. What's important, though, is the fact that organic compounds contain carbon. That's the important part. I mean, you need to know the rest too, but big definition of organic compounds is carbon. Inorganic compounds is everything else. Organic versus inorganic compounds. What makes them different? Organic compounds. Organic compounds are covalently bonded, and that covalent bond is normally nonpolar, except for the cases when nitrogen and oxygen are present. They are usually not soluble in water. You could also call that insoluble, which means usually does not dissolve in water, okay? And they have low melting points, usually lower than 400 degrees Celsius, and that is a low melting point. So those are some characteristics of organic compounds. Please be familiar with these. Inorganic compounds have either ionic or covalent bonds, but if the bonds are covalent, they're normally polar, whereas organic compounds, covalent bond is normally nonpolar. They are more likely to be soluble in water, again, meaning that they can dissolve in water, and they usually have very high melting points, well above 400 degrees Celsius. And a few structural features of organic molecules. They have what's called a carbon backbone. And you'll be seeing this over the next few days. But when you see an organic molecule, there might be a bunch of stuff connected to it, but the major chain, the major backbone is carbon. And maybe you'll have a bunch of hydrogens connected to it, chlorine and OH. But the backbone here will be of carbon. Carbon always it says always makes 4 bonds with other molecules. Notice it says it makes 4 bonds. It doesn't say it necessarily bonds with 4 molecules. The reason for that is that carbon has 4 valence electrons. Carbon can form diverse structures, including chains and rings, and you'll be seeing that over the next few days. And a definition you already know is that molecules with only hydrogen and carbon are called hydrocarbons. All right, let's talk a little bit about carbon, and then we'll be done. Carbon, remember, is the definition of an organic molecule. It contains carbon. So why is carbon so important? Well, carbon always makes 4 bonds, keep that in mind, with other elements. A hydrocarbon with only single bonds is called an alkane. And the simplest organic molecule is methane, which has 1 carbon. So how many hydrogens are there in methane? See if you can answer the question before I do. Carbon has 4 valence electrons, which means it needs to have 4 hydrogens, CH3. Okay, a couple quick thinking questions for you, and we'll be done. All right, so first question, what is the maximum number of atoms a single carbon can bond with? Did you come up with an answer? 4 valence electrons, which means the maximum number of atoms, keep that in mind, the maximum number of atoms a carbon can bond with is 4. Okay, next question. How about the minimum? Let's see. Again, we've got 4 valence electrons. Well, it could bond with oxygen. And you could have other arrangements, but the minimum number is 2. All right, that's it for today.